Hello, I am Dr. Levon Hayrapetyan, a business professor at Houston Baptist University. In this video, I will demonstrate the essence of hierarchical clustering. So far, we already learned how we can measure similarities between two observations. Then we learned how we can calculate measure of similarities between two clusters. Now we have enough knowledge to start actual cluster analysis. The essence of any cluster analysis is to divide the entire set of population or set of data into groups in such a way that elements or observations in one group, or they called clusters, are similar, whereas observations in different groups are dissimilar. So this is the essence of hierarchical clustering. Divide into groups, where within each group they are similar, within different groups, among different groups they are dissimilar. There are several clustering methods, and we'll start with hierarchical clustering. The essence of hierarchical clustering is this. So first, we start by assuming that each observation is in its own cluster, which means if we have 10 observations, that we will start with 10 clusters, and each of them contains a single observation. Then we will calculate distances between those observations or these clusters and find the smallest distance, which means find the most similar two clusters. And when we find those most similar two clusters, then we merge them into a single cluster. Then we will repeat this process, which means, again, we will calculate similarities between new clusters and then find the most similar two clusters and then combine them merge them into one single cluster. So during each iteration, number of clusters becomes one less because we are merging two most similar clusters. So this process will continue as long as either we reach a certain number of clusters which we desire, or when all observations are in one big cluster. So I will demonstrate this on the example which I created in Excel. First, I will demonstrate in Excel, so you will feel the essence of this cluster analysis, and then we will use special software called Analytic Solver. That's the one which you're supposed to download and install, and that's the software which will be intensively used in this class. So let me switch to Excel. Here's my example. I have 6 observations, and each of them has 2 variables, and X and Y. These variables are already normalized. We don't have to worry about normalization. I graphed those observations so you can see how they look like on 2D plot. Now what we want to do is we want to do cluster analysis. We will use simple linkage method, which means simple linkage means when we're comparing two clusters, then measure of similarity will be the smallest between all possible distances between observations in those two clusters. We discussed this method in one of the previous video tutorials. So what we will do here now, first step in hierarchical clustering, we should have as many clusters, as many observations we have, and each cluster is its own observation. So right now we have 6 clusters, and each cluster has only one observation. 1 cluster, 2, 3, and so on. So what I did in here, I calculated. Now the next step is I need to calculate distances between all clusters, pairs of clusters, and then find the most similar 2 clusters. The most similar means with the smallest distance, and merge them together. In order to do that, first I have to calculate distances between all possible pairs of observations. That's what I did in here. why diagonal is 0? Because here are my observations. Here I'm distance between observation 1 and itself. Obviously, it's 0. So diagonal is distance between observations to itself. That's why they are 0. So this is the distance between observation 3 and 1, between 4 and 2, distance between 5 and 1, and so on. Why I left this part empty? Because distance between observation A and B is the same in general as between B and A. For example, here I need to have a distance between 1 and 4, correct? But I already have 4 and 1. I don't need to copy the same number in here. The same reason, this is between 4 and 5, but I already have between 5 and 4. So therefore, this is 0.28. That's why I didn't copy the same numbers in here, similar numbers, because they are redundant. So how I calculated this? I will just show you 1 or 2 examples because we did this several times. Let's pick one. Let's say between observation 3 and 2, which is how I got this number 3 and 2, 0.14. So it will be square root of between 2 and 3. So these are my 2 and 3 will be this minus this. This is Euclidean distance, as you remember. This one minus. This is how I got this 14. So I didn't keep, the solutions file is posted, so you can check all formulas, but I would strongly recommend you try your best first to come up with these numbers. However, and I showed you, it's just simple distances. Like this one will be distance between 5 and 2. So you will use 2, observation 2 and 5, and you use square root, that formula, famous formula. So we calculated all distances. What shall we do now? Now we have to find the smallest because we are looking for simple linkage. So the smallest is this, which is between 3 and 6, which means 3 and observations or clusters 3 and 6 are the most similar. Therefore, we have to merge them into one. And that's what we did here, visually 3 and 6 into 1. Simultaneously, I am creating also so-called dendrogram. And the dendrogram is visualization of clustering, hierarchical clustering process. So how it's created. So this is this 3, this is 6. We have vertical lines, and the height of this vertical line is this number, which is measure of this similarity. So this is my dendrogram after the first merger. Thus, after the first merger, I have one less cluster. So this is one cluster, another 3, 4, 5. Before I had 6 of them. What shall we do now? Now we have to repeat the same process. I have to calculate distances between all these clusters and find the most similar 2 clusters. And that's what I did in here. So I have to calculate distance between this cluster 1 and 5, 1 and 2, 1 and 4, 1 and 3, 6, 2 and 3, 6, 5 and 3, 6, and so on. So between all possible pairs. And that's what here I listed. These are my new 5 clusters. No, the 4 of them are the previous clusters, obviously. 1, 2, now 3 and 6 are together one cluster. That's why I have 3, 6, then 4, 5. The same list is in here. So how I calculated these numbers? Look, this one is simple, like observation, well, the distance between 1 and 2, which we calculated already before. The most interesting is this, how I calculate, let's say, this number, which is distance between this cluster, which is observation 1, and this cluster. So according to single linkage method, I have this distance will be, I have to calculate between 1, 3, between 1, 6, and take the smallest. That's why smallest in Excel will use mean function, mean, and then I have to select between 1, 6 and 1, 3, or 3, 1, 3, 6. It doesn't matter which order. 1, 3, 1, 6. So let's go and see. We already calculated those distances. 1, 3, which is this, and 1, 6, which is this. Right? 1, 3, 1, 6. And this is how I got this 0.22. So again, I encourage you to, when you check the solution, try to do your best and make sure that you can calculate distances between clusters. Next step is we calculate all distances. Now I have to select the smallest one. The smallest is 0.14. I have 2 of them. When you have 2 of them, you can select any of them. So I pick this one between 5 and 2. So the closest, the most similar 2 clusters are 2 and 5. Now I will merge them into a single cluster. That's what I did in here. And I added this to my dendrogram. So this is 2, this is 5. And I drew vertical lines, and the height of those lines is this number, 0.14. You can see approximately 0.14. Now this is my how my dendrogram looks like after this second iteration. Now how many clusters do we have? We have 1 cluster, 2, 3, and 4. We have 4 clusters, and I listed here those 4 clusters. This is 1 cluster. Another cluster consists of 2 and 5. The other one 3 and 6, and 4 single is another cluster. And then I repeat the same process. I calculate distances between all these clusters, between 1 and 1, no, actually 1 and this, so 1 and 2 and 5, then 1 and this, and so on. So let's pick just one and see how I calculate. For example, how you calculate this distance between 4, so which means I want to figure out how we came up with this number. So this is distance between cluster 4 and cluster 3 and 6. So I have to calculate, it will be minimum between 4, 3 and 4, 6. So it will be minimum, and we already calculated 4, 3, and it was 4, 3, 4, 6, right? 4, 3, 4, 6, yes. Minimum of 4, 3, this is my 4, 3, and 4, 6, which is the same as 6, 4. And this is how I got this 0.16. Similar way, you can calculate all other distances. Solution file contains all formulas. Now the smallest is this, which means we have to merge these 2 clusters, cluster 2, 5 with the cluster 3, 6. And this is my cluster 2, 5, cluster 3, 6, and I'm merging them into a new cluster. And I am also adding, this was my 3, 6, 2, 5, and I am merging, and the height of this will be 0.14. Since this 0.14 is the same as the previous one, like this one, that's why this line is just continuation of this. The height is 0.14. Now I have, how many clusters remain? 1 cluster, 2 cluster, and 3 cluster. So cluster, this is 1 cluster, 2nd cluster, 3rd cluster. Now I continue the same process. I calculate distances between all these clusters and find the smallest one. Let me show just one of them how to calculate distance between. Let's say how I got which one? This one, 0.22. Let me calculate here. So this will be distance between 1 and this big cluster. So it will be minimum of 1, 2, 1, 5, 1, 3, and 1, 6. So it will be minimum of 1, 2, 3, 5, 6. One, 2, 1, 3, 1, 5, and 1, 6. So minimum of those elements. And that's how I got this 0.22. The smallest is 0.16. And in this cluster, which means the smallest clusters are cluster observation 4 and these 2, 3, 5, 6 together. So that's why 4 was merged with this one. And here I am continuing my dendrogram. I added the vertical line above the 4, and the height of this line is 0.16. And then I connected this with the horizontal line to the other cluster. And finally, now we have 2 clusters, and actually, if it's only 2 clusters, obviously the next step is to combine them into 1, but I calculated the distance just to know how much is the height of this vertical bar, and it's 0.22. So this is how hierarchical clustering works. Let me summarize it. In hierarchical clustering, we start with the assumption that each observation is its own cluster, which means at the beginning we have as many clusters as many observations. Then during the iteration, what we do, we find the most similar 2 clusters and merge them together into 1. And then we repeat this process over and over again. So during each iteration, we find the most similar 2 clusters and then merge them together. And simultaneously, we also learn how we can create a dendrogram, which is, so this is the final dendrogram, which demonstrates the hierarchical clustering process. In another video, I will show you how we can interpret the dendrogram. This concludes my video. Bye-bye.